Okay, let's dive right into this. Welcome back to The Explainer. Today, we are unpacking a true cosmic detective story. And honestly, it's one that deals with the very fabric of our universe and exactly how we experience it. We're looking at a deeply brilliant conceptual framework from our source material, which is titled Stabilizing Many Worlds via Primitive-Born Weights. Now, if you've ever found yourself totally intrigued by quantum physics, but maybe a little bogged down by the ultra-abstract math, you are absolutely in the right place. We're going to break down this complex theoretical paper into really clear, understandable steps. It is amazing how just a simple shift in perspective can actually solve one of the biggest, most persistent headaches in all of theoretical physics.
Here's our roadmap for the explainer today. We're going to start with the many worlds problem, then we'll move right into the reality fluid solution, explore keeping Schrödinger pure, ask the question, where am I now? And finally, wrap things up with the observer filter. All right, part one, the many worlds problem. And yeah, it's a real foundational headache. So the many worlds interpretation of quantum mechanics has this incredible appeal, right? It's mathematically elegant, and let's be honest, it's theoretically just really, really cool. But it creates a massive headache. Think about it. If the universe splits so that literally everything that can happen does happen, how can one outcome possibly be more probable than another? I mean, if both outcomes actually occur, how do we make any sense of standard quantum probabilities? This isn't just some abstract third-person math problem. It leads to a deeply personal first-person existential dilemma. Which branch am I in? Our source material points out that right after a quantum event happens, an observer faces what's called self-locating uncertainty. You know the universe just branched, but you don't know which branch you're currently experiencing. We absolutely need a way to weigh these branches to make sense of our everyday reality. Moving to part two, the reality fluid solution. Time for a major perspective shift. So our source material introduces an incredibly elegant fix to this probability problem. Instead of trying to mathematically force probabilities out of a system where everything happens anyway, the solution lies in treating born weights, which in physics refers to the squared amplitudes of a wave function, as a primitive fact. Now, what does primitive fact mean? It simply means it's a foundational, non-derivable property of the wave function's measure. It just is. And the authors use this fantastic visceral metaphor that I absolutely love. Reality fluid density. Rather than treating the math as dry, boring numbers, imagine the wave function as an actual fluid, where some branches simply have a higher density of reality than others.
Now, what's really interesting about this breakdown is how it debunks a massive misconception. When people hear many worlds, they almost always rely on naive counting. They assume two outcomes automatically mean an equally real 50-50 split. But treating born weights as a primitive fact means these branches can have wildly different amplitudes. Branch A might hold, say, 80% of the reality fluid density, while branch B gets just a 20% splash. They are not equally real in a simple one-to-one counting sense. Yes, the branching happens deterministically, but the literal existential weight of that branch is totally unequal. Section 3, keeping Schrödinger pure. Why should we actually adopt this?
We've established this really cool concept of reality fluid, but why should the broader scientific community actually adopt it? Well, our text transitions into the evidence phase of our cosmic detective story, outlining 4 distinct pillars that give this theory its immense appeal. 1. Mathematical parsimony. 2. Avoiding common pitfalls. 3. Self-locating uncertainty fits naturally. And 4. Observer viability as a totally separate constraint. We're going to anchor ourselves to these 4 pillars as we take a deeper dive into the mechanics.
Let's look at the first pillar, mathematical parsimony. The sheer beauty of treating born weights as primitive reality fluid is that you do not have to break the math to make it work. The Schrödinger equation remains perfectly, beautifully pure. There's no mysterious, spooky collapse of the wave function. There are no invisible, hidden variables operating behind the scenes, and absolutely no ad hoc, clunky modifications bolted on just to make the numbers look right. The branching structure of the universe simply is what it is. Now, the second pillar helps us avoid some really common traps. The old, flawed approach tries to derive probabilities from the idea of equally likely branches. But there is a glaring issue with that kind of thinking. The term branch isn't even sharply defined before a system undergoes decoherence. You literally can't count them. That makes naive counting impossible. The new approach completely sidesteps this trap. By simply declaring the weights, that reality fluid density, as fundamental and primitive, you never have to worry about counting individual branches in the first place. Problem solved.
Part 4. Where am I now? Getting back to standard statistics.
So, if we fully accept this reality fluid density, how do we get back to the standard quantum statistics that physicists observe in the lab every single day? How does this framework recover the math without falling into the trap of circular logic? Well, it happens in three distinct, incredibly logical steps. Step 1. The universe decoheres into effectively orthogonal components, meaning distinct, non-interacting branches. This happens unitarily and deterministically. Step 2. The observer wakes up, so to speak, in one of these branches and faces valid, indexical, self-locating uncertainty, meaning they look around and ask, wait, which branch am I actually in? And finally, Step 3. That uncertainty is weighted directly by those primitive Born measures. Because the uncertainty is weighted by the reality fluid density, standard quantum statistics are recovered perfectly, naturally, and with absolutely zero circularity.
And finally, Section 5. The observer filter. Anthropopic selection.
Here's a huge question. If everything happens and branches have wildly different weights, why does our specific universe look the way it does? How do we account for the very precise conditions required for human life to exist? Well, the framework handles this so elegantly through anthropic-like selection. It states that only branches with sufficient complexity, stable chemistry, and so on actually contain observers to ask these kinds of questions in the first place. This existence constraint acts purely as a filter on where observers can meaningfully exist. And honestly, the most brilliant part, it applies this filter without ever messing with the underlying probability weights. The primitive reality fluid density remains completely 100% untouched.
This brings us to a quote that brilliantly illustrates the broader philosophical elegance of the text. By treating the Born weights as fundamental and the observer constraints as just a mere filter, the authors explicitly separate existence from typicality in cosmological multiverses. Think about that. Just because a branch exists and has observers in it doesn't mean it's the most typical experience, or that it has the highest reality fluid density. It allows the universe to be vastly, mind-bogglingly complex without confusing the probability of an event with the mere fact that we happen to be alive to witness it. We have journeyed through the entire many worlds problem. We've discovered the incredibly elegant reality fluid solution, seen exactly how it keeps Schrödinger's mouth perfectly pure, and learned how it filters for our very existence without corrupting the underlying physics. It is just a stunningly clean way to stabilize a totally mind-bending theory. So I'm going to leave you with this thought to ponder as you go about your day within this untampered, ever-branching wave function. What do you think is the reality fluid density of your current branch? Thanks so much for learning with me today on The Explainer, and definitely keep questioning the nature of your reality.